Okay, so let's try to do the third problem. What is the third problem? Yeah, this one. It's a little bit out of focus, but I hope you can actually see this one. So it says that normal boiling point of ethanol is this temperature right here, and the molar heat of vaporization is given right here. What would be the vapor pressure in torr of ethanol at 50 degrees Celsius? So that's pretty much all we have here. Of course, that you can actually see the answer here, but I'm gonna do everything in Excel, and I'm gonna explain why I would like you to actually use Excel, because this is gonna change your exam score really drastically. So bear with me for a while. Okay, so first thing first, I gotta go back and forth because my memory isn't very good. So so 878. Okay, so the stuff that we know is that we are given two conditions, right? One at one condition at the boiling point, wasn't it? I already forgot. What was the thing? 78.3 degrees Celsius. If you can't see anything, that's fine. That's 78.3 degrees Celsius. That's the temperature, T1, and then at this point it's boiling, right? So it's gotta equal to the atmospheric pressure. So that's 760 torr or 1 atm. And then the second condition is temperature, which is that one. Okay, so that's second condition is that 50 degrees Celsius, but we don't know the vapor pressure at that moment. So 50 degrees Celsius. Second conditions, temperature T2 is 50 degrees Celsius, but pressure unknown. It's P1, P2. And third information is that we already know the heat of vaporizations. That heat of vaporization is 39.3. The delta H VAP is 39.3 kilojoule per mole. So that's pretty much all we have for these guys. Okay, so let's just try to use these informations to build our highly useful Excel worksheet. So to do that, I'm gonna change the sheet. So notice that my mouse actually goes to sheet 2. I'm gonna click that one, then I get a brand new sheet. The sheet 1 is always there, you can always go back, but sheet 2, I'm gonna use it for this particular program. The same as the previous one, my eyes are messed up so bad that I gotta change that to a bigger font. And I'm gonna use 18 so that I can see something from here. So I'm gonna write out as a condition 1, I got the temperature T1, and then P1, and then T2 is also known, and then delta H of vaporization is already known. Unknown is P2 for this particular case. So this I should probably change that to known. Known informations, all of these things are known, and then unknown is this guy right here. Okay, so what we are going to do next is to fill in the stuff that we already know. It's 78.3 degrees Celsius, but you know that this thing has to be Kelvin, and P2 can be tau, then that needs to be in tau, and delta H of vaporization is in joule. I'm going to change that to the joule per mole. So that one right there is going to be 39,300 joule per mole. The reason why that I use joule is that R right here R equal 8.31. That's also joule, something to do with the joule. So that's also a known information. So I'm going to put the yellow one here. And then the Kelvin, that's 78.3 degrees Celsius. And then the other one is 50 degrees Celsius. So to get to Kelvin, you have to add 273, right? Plus 273.15, and you do the same for here. This plus 273.15, you get that, and then the tau is 760. Okay, so these are all the information that we need. Now let's do the algebra for a while. So I go back to the screen, which is gonna open up these things. Now the formula that we use is for this one is log of P1 divided by P2. Can you see this one? Is it too small? Is equal to delta H BAP divided by R of 1 over T2 minus 1 over T1. Right? Now, first thing that P2 was unknown, right? That's the unknown. So I want to actually solve for this one, but I don't need this log. So what we do to actually eliminate this natural log is to put exponent in front on both sides. E to the power of log of something is equal to e to the power of the whole thing. Then what's going to happen is that e and log is going to cancel. P1 divided by P2 is equal to e to the delta H divided by R of 1 over T2 minus 1 over T1. It's e to the power of these things. Now, I want to isolate P2, right? If you want to isolate P1, then you just multiply both sides by P2. But I want to isolate the P2. So P2 goes that way, e to something goes to this way, right? So let me put it this way. The P2 is gonna be P1 times e to the minus delta H divided by R of 1 over T2 minus 1 over T1. So that's how the equation that I need to actually isolate P2. So let's do that one. So going back to the Excel worksheet. To get to this, I'm gonna go directly onto these things. Equal P1 multiplied by exponential, and then you have a e to the power of this parenthesis minus delta H of vaporization divided by 8.31. Let's just write down 8.31 multiplied by another parenthesis 1 over T2. T2 is this guy minus 1 over T1. Parenthesis close. And then I'm going to have to close this parenthesis, right? Because this parenthesis is closed right here. Another parenthesis needs to be closed. So that needs to be closed. Then voila, you get that. So that's P2. So that you already got this answer to this problem. But hear me out from this point on. You can actually do these things for 5 other cases. What happens if you happen to know, let me just copy everything. Just copy everything right here. What happens if I know that T1 and P1 and T2 and P2, but unknown is the delta H of vaporizations? What's gonna happen to this guy right here? Then what you need to do is once again go back to the paper and then solve this particular formulas. Let me just write out another stuff, which is log of P1 over P2 is equal to delta H BAP divided by R of the T2 minus T1. Then you're gonna have to solve for this guy, right? So you're gonna have to divide both sides by this and then multiply by that. Then you can actually isolate delta H of vaporizations. So delta H of vaporization is equal to this divided by that multiplied by this, right? And you do that in right here, basically, by yourself. And then you do that for the what happens to other case, like what if I don't know the P2, not the P1? Then you make another case right here in the next portion right here. And then what happens if you don't know the P1? Then you do that for somewhere around here and T2. Then basically no matter what type of problem that you face for this type of problem, is that only thing you have to have is that you just need to get these numbers. That's pretty much it, right? Or that numbers, right? So you can do that. Then once you get that, then this number, you already get it automatically. So to solve the problem like this, you can actually do this problem in less than couple of minutes. Identify what's not known, and then identify what is known, and then just plug into the right formulas. And that's pretty much all I have to say. So that's pretty much your homework. So what I want you to do is to create the Excel worksheet that works for at least 3 of them. But if you are not very good with algebra, then I recommend you to actually do all 5 of them to prep for it. Once you create this formula sheet, then try to solve some problems on the textbook. It's going to be super easy for you. So that's pretty much all I have to say about that.